Hello students, in this lecture we are going to start a new module which is the mineralogy. So first is the what is meant by the minerals. A mineral is a naturally occurring homogeneous substance which has a more or less definite chemical composition and definite atomic structure. As we know that all the rocks are made up of different types of the mineral. Okay, so study of the minerals is very much important for the at the time of the study of the rock. So first we are studying the minerals. This mineral is a naturally occurring, means this is not a man-made material. Okay, and it is a homogeneous substance which has a definite chemical composition and also the atomic structure. These minerals are usually formed by the inorganic processes, and these minerals have a constant set of the physical properties. Okay, so each minerals have a physical properties also, then the chemical composition also, atomic structure. Okay, but for the determination of this atomic structure and the chemical composition, it requires a laboratory test. Okay, so but these minerals can be easily identified uh, by the physical properties. Yeah, so the physical properties is very much study of these physical properties is very much essential, because with the help of these physical properties we can easily identify the different types of the minerals without a testing. Okay, without any laboratory test we can identify these minerals. As these minerals are divided into two groups. First is as a rock forming minerals, and second is the ore forming minerals. Rock forming minerals means what? Which are found in the abundance of the rocks of the earth crust. Rock forming minerals are those which are found in abundance in the rocks of the earth crust, while the overforming minerals are those which are of economic value. That means which are not occurs in the abundance in the rocks. Okay, so the rock forming minerals means what? Which are available in the abundance. So and the overforming minerals are those which are available, which are not occurs in the abundance in the rock. Okay, so it has some economic value. These are the two different types of the minerals, or we can say these are different types of the groups of the mineral. Okay, so about 200 to 1000 minerals are known to exist. Over 2000 minerals are known to exist, but most of them are rare. The minerals which are common in the rocks are small in number. They are about 29. Okay, so 200 minerals we know that they are exist, but among them only 29 minerals are available, occurs in the common rocks. So it is also interesting to note down that the 8 elements composes the bulk of these minerals and about 98% of the continental crust. Okay, so all these minerals are of contains different elements, but the 8 elements which are uh, where- the 8 elements which compose the bulk of these minerals and about 98% of this continental crust. So these minerals are, or the elements which are composing, which the 8 elements which composes the bulk of these minerals and the 98% of the continental crust are oxygen, then silicon, aluminium ion, calcium, potassium, sodium and magnesium. So these are the 8 elements. Out of this element, the two abundant elements like a silicon and the oxygen, okay, which combine to form the mineral group which is called as silicates. Okay, so silicates are available in the abundance. Okay. So in this slide you can see the table is there which is showing uh, the 6 groups of these minerals. So first type of the mineral group is the oxide, second type is silicates, third type of the mineral is carbonates, then sulfide, sulfates and the chlorides. All the minerals are grouped into these 6 types of the minerals. The examples also they are given. The example of the oxide is quartz, magnetite, hematite, limonite. Example of the silicates are mica, then hornblende, okay, feldspar, then carbonates. Examples of the carbonates are calcite, dolomite, okay. Then sulfides, the examples of the sulfides is pyrites, galena. Examples of the sulfates are gypsum, and the example of the chlorides is the rock salt. Okay, so all the minerals are grouped into these 6 types of the 6 groups. Okay, then we will see the physical properties of the mineral. These physical properties of the minerals can be determined readily by the inspection or by the simple test. For identifying the atomic structure and the chemical composition, we have to do some chemical test, or we have to do some laboratory test. But for identifying the physical properties, we can identify these minerals by simple inspection or by a simple test, because these physical properties are determined in hand specimens. They are important in the recognition of the minerals in the field. So the physical properties are color, streak, luster, hardness, habit, cleavage, fracture, odor, feel, tenacity, fluorescence, phosphorescence, magnetism and specific gravity. So these are the physical properties of the mineral. The correct identification of these minerals is made with the help of the polarizing microscope. Okay, so sometimes the polarizing microscope is also used for identification of these minerals, or for the correct identification of the mineral. This involves the grading of the minerals and rocks into the thin slices and allowing the polarized light to pass through them. So means what? The minerals which we have to identify, they are breakdowns into the small slices, and then the pulverized light is passed through them. In this way, their optical properties are studied and the minerals are identified. Okay, then we will see each physical property in uh, detail. The first property is the color. The color of the mineral is due to the absorption of the certain wavelengths of the light by the atoms which are making the crystal. The remaining wavelengths of the white light that are not absorbed give rise to the color seen by the observer. Means what? The dark color minerals absorb most of the light, whereas the red color minerals reflect or transmit the mainly the red light or absorb all others. Okay, means what? The dark color minerals जो है वो most of the light absorb करते हैं, ओके। वेयर एज रेड कलर मिनरल जो है वो रिफ्लेक्ट करते हैं रेड लाइट एंड ऑल्सो एब्सॉर्ब ऑल अदर्स। रेड लाइट को एब्सॉर्ब कर रेड मिनरल जो है वो रिफ्लेक्ट करते हैं रेड कलर एंड एब्सॉर्ब ऑल अदर्स कलर। देन some minerals possess the characteristics and fairly constant color. So minerals में constant color होता है. For example, lead gray of the galena, then brass yellow pyrite, green of the chloride. Okay, so they shows this mineral shows the constant color. For some color, but in the case such as quartz, the color is variable and cannot be relied on as a guide to identify the minerals. The quartz showing the different colors. Okay, some minerals have the constant color. Okay, but some minerals are available in different colors. For example, the quartz are available in different colors. The presence of some amount of the impurity can give the variety of the colors to the white. In the in the if suppose the mineral is of white color, but if any impurities is present in its minerals, then it can uh, it can give the variety of colors to the white or the colorless minerals. For example, the color of the amethyst and the rose quartz is due to the presence of the titanium and the manganese in the traces. The most common coloring impurity is hematite. It imparts red color to many minerals including some feldspar, calcite and jasper. Suppose some minerals, if we see or if we viewed in different direction, then they can show the irregular changes in their color, and this is called as play of the color. अगर हम कोई भी मिनरल्स डिफरेंट डायरेक्शन में देखते हैं तभी उनका कलर डिफरेंट डिफरेंट लगने लगता है, तो इसे क्या कहते हैं, प्ले ऑफ द कलर. So our next property here, in this figure you can see the color collection. The beryl is having a green color, sulfur is having a yellow color, then jasper is having a red color, amethyst is having a blue color. Okay, this is a color collection of the minerals. Next, our next property is the streak. Streak means what? The color of the mineral powder is called as a streak. Streak. And this streak is obtained by rubbing the minerals against an unglassed porcelain plate, which is called as streak plate. Okay. If we take any mineral and it is dropped on this porcelain plate, then the mineral powder is obtained, and this mineral powder, the color of this mineral powder is called as a streak. The study of the streak is almost useful in the case of the colored minerals, which often give the very much lighter streak than their body color. Means what? For example, the hematite, which appears like a black. Okay, the color of the hematite is black, but uh, if we strike this or rub this hematite on this porcelain plate, then it gives a red colored streak. Okay, so the streak is very useful for identifying the most of these silicates, carbonates, transparent minerals because they give us a white streak. So this is our second property, second physical property of the mineral. Third type is the luster. Luster is defined as an general appearance of the mineral surface in the reflected light. Means it is a very characteristics or the useful property of this mineral. It is the measure of the reflectivity of this mineral surface. The appearance of the mineral surface in the reflected light is nothing but the luster, and this luster is of different types: metallic luster, submetallic luster, adamantine luster, then vitreous luster, pearly luster, silky, resinous, greasy, and dull or earthy luster. So these all are the different types of the luster. So in the figure you can see they have given the luster collection. So the first one is an pyrite. Pyrite showing the metallic luster means what? The minerals which are appearance like a metal, it is called as a metallic luster. Pyrite and also galena showing this metallic luster. Okay, so our next type is the vitreous. Vitreous means what? This it is the luster exhibited by the broken glass. For example, quartz. Quartz is an example of the vitreous luster. Then the resin. It is the luster which is exhibited by the resin. Example is the sulfur. Okay. Nantar. Next is the submetallic luster. The feebly displayed metallic luster is called as submetallic luster. Okay. The hematite and chromite is an examples of this submetallic luster. Metallic luster means what? The minerals are look like as a metal. Okay, this is a metallic luster. Then pearly luster. Pearly luster is exhibited by the pears. The examples of this as muscovite, tal, calcite. Okay, so this is all about the luster. Our next property is the hardness. Hardness is one of the most important or most useful diagnostic property of the mineral. It is defined as a resistance of the mineral to abrasion and stretching. This hardness is determined by rubbing of the minerals of unknown hardness against one of the known hardness. Okay, hardness is identified um, determined by rubbing a mineral of unknown hardness against one of the known hardness. The numerical value is obtained by using the Mohr scale of the hardness. So here this is a Mohr scale of the hardness. In this scale there are 10 minerals which are arranged in the order of their increasing hardness. Okay, so hardness of 1 is hardness of talc is 1, hardness of gypsum is 2, whereas calcite is 3, fluoride is 4, apatite is 5, orthochlorous is 6, quartz is 7, topaz is 8, corundum is 9, and diamond has hardness of 10. So this is the Mohr scale of the hardness. The talc is softer while as diamond is harder. Okay. And then our next in this figure you can see is all the hardness. All the minerals are arranged according to their um, hardness scale. Okay, here is the talc which is having a hardness of 1, then gypsum, calcite, fluoride, apatite, and at the end of this the diamond is there which is the hardness hardness of this diamond is 10. Okay. Our next property is the habit of the mineral may be defined as the size and shape of the crystal and the structure or form shown by the crystal aggregate and the cryptocrystalline masses. The types of the habit is acicular, fibrous, foliated, blended, tubular, columnar, reniform, granular, piezolytic, oolitic, and massive. Okay, so here is the first is the in this figure you can see the columnar form is there. Minerals showing the columnar crystals. Okay, so the examples of this is that tourmaline is an example of this columnar structure. Minerals appear like as a long slender prism, columnar crystal. Okay, then second type is the fibrous form. Minerals which are showing an aggregate of long thin fibers are the is showing the fibrous form. Means what? The minerals are appears to be made of thin sheets. In the asbestos, you can see the minerals is appearing to be a thin sheets. Thin threads are there. So this is an examples of the fibrous form of the mineral. Asbestos is an also the satin spar is an example of this fibrous form of the mineral. Then the blended form minerals which are showing the uh, bladed habit occurs as a small knife blades are called as a bladed form. Means what? The minerals appear as a cluster or independent layer shaped grains. Then they are called as a bladed form. This is the figure which is showing the bladed form. This is the granite. Next is a tubular form. Tubular form means what? When the mineral showing the broad flat surface. Okay, minerals appear as a slab of the uniform thickness. Then it is called as an the minerals is showing the tubular form. For example, the feldspar. Next is as a massive form. When a non-crystalline or cryptocrystalline minerals occurs as a structureless mass, then their habit is described as a massive. So here the definite shape is given to the minerals. They uh, they are in the structureless form, less mass. Then it is called as a massive form. Okay. Then the next type of this next property of the next physical property of the mineral is the cleavage. If a mineral is breaks along a flat plane, it is said to be as a cleavage. कोई भी मिनरल अगर फ्लैट प्लेन में ब्रेक होता है तो इस प्रोसेस को क्या कहते हैं? क्लीवेज. But if they break in an irregular surface, then it shows the fracture. अगर कोई भी मिनरल फ्लैट प्लेन में ब्रेक होता है तो हम उसे क्लीवेज कह सकते हैं. While the mineral is break down into the irregular surface, then it shows the fracture. So the cleavage is defined as the tendency of the mineral to break more easily with smooth surface along the planes of the weak bonding. Means it is a property which is related to the organic arrangement within the minerals. The types of this cleavage are uh, cubic, octahedral, prismatic, basal. So these are the types of the cleavage. Here is the figure which is showing the different types of the cleavage. So first is as a mica. Okay, in the first uh, in this table you can see the first is the mica which is showing the basal cleavage. Talc is also showing the basal cleavage, while the galena and hemita is showing the cubic cleavage. Okay, then the calcite showing the rhombohedral cleavage, and the orthoclase showing the prismatic cleavage. These are the different types of the cleavage. Next type is of the physical property is the fracture. Minerals which do not exhibit the cleavage break with an irregular surface. The, the nature of this broken surface is called as fracture. कोई भी मिनरल अगर इरेगुलर शेप में ब्रेक होता है तो उसे क्या कहते हैं, fracture. And in the case of the fracture, the breaking should be in any other direction with the than the cleavage. क्लीवेज में क्या होता है, वो ब्रेक वो फ्लैट ब्लेड में ब्रेक होता है, बट फ्रैक्चर कोई भी डायरेक्शन में जब कोई भी मिनरल ब्रेक होता है तो उससे फ्रैक्चर कहते हैं. ओके, so fracture is also having the different types: conchoidal fracture, even fracture, uneven fracture, and the hacky fracture. These are the four different types of the fracture. So first in the figure you can see the different minerals they have given. Okay, so first is a limestone which is showing the even fracture. Even fracture means what? The fracture surface which is almost flat. Okay, here the limestone showing the even fracture means the surface is almost flat. Okay, whereas the beryl showing the uneven fracture means what? The fracture which is irregular or and rough. Then it is called as an uneven fracture. So here chromite and the beryl showing the uneven fracture. Next type of the fracture is the conchoidal fracture. It is the curved fracture surface showing the concentric line like a shell. Then it is called as a conchoidal fracture. Quartz and the glass show the conchoidal fracture. And last type is an hacky fracture. The copper showing the hacky fracture. Hacky fracture means what? The fracture surface which is rough and the sharp and jugged points. Then it is called as hacky fracture. The copper showing the hacky fracture. Our next type is the odor or the taste odor or the taste. Next physical property of the mineral is odor or the taste. Some minerals show giving the characteristic smell when rubber broken along or heated. If कोई भी मिनरल अगर हम हीट करते हैं और किसी के ऊपर भी रब करते हैं तो स्पेसिफिक कलर आता है, तो उससे स्पेसिफिक ओडर आता है रबिंग की वजह से और हीटिंग की वजह से. ओके, so this the types of the odor are arsenial, supercilial, agricilious. Okay, so the taste are also salty taste, then earthy, clay smell is of different types, unusual, odor, there is super sulfurous odor, smell, ionic smell, lime smell, earthy clay smell. This is the different types of the smell. And the taste is also salty taste, sweetish taste. These are the types of the taste. Next property, physical property is feel. Feel is nothing but the sensation upon the touching or handling the minerals. अगर कोई भी मिनरल्स हम हैंड में लेते हैं तो वो जो सेंसेशन टचिंग का है उसे क्या कहते हैं, हम फील बोलते कहते हैं. द डिफरेंट टाइप्स ऑफ द फील आर ग्रीजी, सोपी, रफ एंड हार्श. And the example of the greasy feel is dull, soapy feel is kaolin, and rough feel is an bauxite. Next property is the tenacity. Tenacity means what? Tenacity denotes the degree or the character of the cohesion. And this tenacity is divided into the different types: spectral, malleable, flexible, elastic, brittle, friable, pulverulent. So these are the different types of the tenacity, which denotes the degree or the character of the cohesion. Flexible means what? The minerals which may be bent. Elastic means what? The minerals which spring back after the bending. Malleable means what? Minerals which flatten under the hammer. So these are the different types of the tenacity. Next property is the fluorescence. Some minerals, when exposed in the sunlight or the ultraviolet light, it produces the color quite different from their own. Then this property is called as fluorescence. अगर कोई भी मिनरल हम सनलाइट के इधर लेते हैं, अल्ट्रावायलेट लाइट उसके ऊपर पास करते हैं, तो वो जो मिनरल है कभी कभी वो उसका ओरिजिनल कलर से वो अलग दिखता है. दिस प्रॉपर्टी ऑफ द मिनरल इज कॉल्ड एज फ्लोरेसेंस. For example, a green or the colorless fluoride shows a blue or the purple color in the ultraviolet rays. Okay, if you take the fluoride in the ultraviolet rays light, then it shows a blue or the purple color. The calcite and the steelite is also gives the different colors when the ultraviolet rays light are passing through it. So this is also the fluorescence is also as a physical property of the mineral. Next type is the phosphorescence. Some minerals glow and emit light when they are placed in the ultraviolet rays line and certain electrical radiation. The glow indicated in the minerals may continue for a few seconds or minutes after the removal of the cause. This property of the minerals is called as phosphorescence. The examples of these minerals is the diamond is an example of the phosphorescence. कोई अगर हम अल्ट्रावायलेट रेज किसी के भी ऊपर किसी मिनरल के ऊपर छोड़ देते हैं, okay, और after some time if we remove this ultraviolet rays, then also for the few seconds or the few minutes the glow, these minerals are glowing. Okay, this property of the mineral is called as phosphorescence. Okay, the diamond showing this property. The examples of the minerals which showing this phosphorescence is a diamond. Next property is the magnetism. A few minerals are attracted by a magnet. Of these minerals, magnetite are most common examples, which is attracted by the magnet. The magnetite that possesses the attractive power and polarity is called lattice. So this is also the physical property of the mineral. And last property is the specific gravity. Specific gravity, it is the number which represents the ratio of weight of the mineral to the weight of an equal volume of the water. Means the formula for the specific gravity is W1 upon W1 minus W2. W means showing the weight of the mineral in the air, whereas W2 is showing the weight of the mineral in water. So the specific gravity is also a uh, is also one of the physical property of the mineral. The minerals which having a specific gravity 4 is 4 times as heavy as an water. कोई भी मिनरल की स्पेसिफिक ग्रेविटी अगर 4 हो तो वो हेवी होती है वाटर से 4 गुना. Okay. The specific gravity of some common silicate minerals is about 2.65, and the specific gravity of some ore minerals varies between 4.5 to 10. So they are very much weight than the water, or we can say they are very much heavy than the water. The ore minerals is the specific gravity of the ore minerals is varying from 4 to 4.5 to 10. Okay, so up to here we have seen the different physical properties of the minerals. Okay, so thank you.